I am Abhiraj. Today with Gauri and Kiran, we will explain termination detection and distributed system. Let's get started. So, uh, in a distributed system, multiple systems run on different nodes and communicate through messages. The termination detection means figuring out when all the process have finished this work and no messages are in transit. Basically, when the computation is complete. Important note, the message used in the actual computation are called basic messages, while messages for detection termination are called control messages. So what is the challenge uh, in this process? We need to know when the computation has finished, which requires two things. All the processes must be ideal and no message should be in transit. Uh, the difficulty, there's no shared memory or global clock in distributed system, make this state hard to detect. Now let me hand over to Gauri for the solutions.
Thanks, Abhiraj. The disaster skeleton algorithm solves this using a tree-based approach. Here's how computation starts at a root process. When a process sends words to another, it becomes that process parents. When a child finishes its words, it sends a message to back to its parents. Finally, when the root is idle with no active children, termination is detected. Let me break down this. The root process starts computation when the process P sends a message to Q. Q become P's child. When Q is idle with no active children, it sends a done message to parent P. When the root is idle with no children, termination is declared. Now Kiran will show you the actual implementation of this algorithm.
Now let's see how the algorithm works in practice with Python code. Here we have multiple processes running as a threads. Each process can send and receive message through queues. When a process receives work, it becomes active and may send message to other, making them children. Once a process is finishes, all its works its work and has no message left, it becomes passive and send an acknowledgement back to its parents. The root process 0, start the work. When it finally becomes passive and there are no message in transit, we know the entire system has finished and we print global termination detector. This simulates how distributed system detects when all works across different nodes in complete, simple, elegant, and efficient. See the definition of termination detection. Now, for the formal definition, let P I denote T denotes process, PI state at time T, and CIJ for T denote message in transit from process I to J. A computation is terminated at time T 0 if all processes are ideal and all channels have zero messages in transit. Both conditions must be satisfied simultaneously. To conclude, the Dijkstra algorithm provides a robust method for termination detection in asynchronous systems. It uses message flow to build a spanning tree and ensure strict message balance. Guaranteeing termination is declared only when the activity has truly ceased. Thank you for watching.